So welcome to this video. This is the step 0 of the course. We have to learn some basics to progress in this course. These basics are very easy, and if you know about this you can just skip it. Just in case you don't know, I'm gonna cover the absolutely important basics that we need to understand the course. So the first topic is going to be sampling. So all type of functions that we deal in mathematics are continuous functions. Continuous functions mean, say this is a continuous function, this is a continuous function of sine, and continuous means that if I take an area, say I take this area over here, if the function is continuous, we're gonna have infinite values of points, infinite points, and infinite values of points over here. But that is not how we do stuff in real life, because in real life we cannot implement the infinity. Can we take infinite points and then plot it? No, we cannot. So what we do is we take a very good approximation. It's not infinity, but it's a lot of points. We take a lot of points and then we plot it, getting us a approximate and very small error in our calculation. We get a very small error in calculation and we can consider it negligible. So if you remember from your algebra courses in the primary school, secondary school, primary secondary school, we used to draw graphs, we used to plot a lot of points and then just join the points one after another. It's like this case, there are a lot of points, right? We have plotted a lot of points, and if we join all the points we will approximately get this curve. You can see if I join all these points, it's gonna give me this curve. Okay. So this is one type of digitization. So what we have done is we have taken discrete amount of points on the x-axis, okay, discrete amount of points on the x-axis, and we have plotted the amplitude versus that point. It's not continuous obviously, but there are a lot of points, and so you can easily just complete the graph and get a very good approximation. In case you have used MATLAB before, you must have used this to plot your functions, because there are no other ways to plot the functions except taking some discrete time interval and the values against that, and then using the plot function. The plot function just added 2 points, just join 2 points with a line, a straight line, and when the number of samples is very high, you got a very smooth curve, and when the number of samples was low, you got a pretty rough curve. And so, well, this can also be denoted like this. Over here, this is not a regular plot function, this is a stem function. You should check the stem function out on MATLAB. It's a stem function, and these points are not joined over here. These points are just kept isolated. But so, well, this is what we call sampling. So what happens in sampling is we take a continuous function and we run it through a block of samples, a sampling block that converts the continuous time domain to a discrete time domain. So this is a discrete time domain. After sampling, we're gonna get this. So now we have to know about this Nyquist theorem. So according to Nyquist, if we want to replicate a curve after sampling, if we're doing samples, after doing sampling, I'm losing some of the information, right? Like the points over here, there is no information about these points over here. Now there are information about these points in the continuous curve, but in the discrete curve there is no information in the middle points, so I am losing information by making it discrete. So according to Nyquist, if the sampling frequency is not two times or more of the signal frequency, we are going to lose the signal. We cannot ever recreate the exact signal again. We need at least two times more frequency than the signal frequency. So if I remove this curve and then let me show you why two times the signal frequency is necessary. Yes, it's an old sine wave curve, and say so 1 second, so 1 second it completes one cycle, so its frequency is 1 hertz. The signal frequency, 1 hertz. So according to Nyquist, what do we have to do? Nyquist says we need 2 into the signal frequency, which will be 2 hertz sampling frequency, to reconstruct this plot. So the sampling will be like this. See, the sample, what it did was it just took the maximum point, and even with two samples the curve will be very rough. The curve will look something like this. I mean, there is a upward slope and a downward slope and an upward slope, but it's a triangle wave. You cannot just create this sine wave, the smooth surface, because of the lack of enough sample. Now, if it happened that we had only one samples in this whole case, then what would happen? Go something like this. Good old sine wave curve, and got just one frequency, say over here or over here, then we cannot reconstruct the signal at all. So just look, what does this signal do? Nothing. There is no point over here. So if I continue this, there will be another sample over here, so the signal will go like this. So basically we are losing the signal. We need at least twice the signal frequency to construct the curve, the basic characteristics of the curve. More the simple, the better the quality of the image, quality of the plot. My bad, it's not image, it's plot. So yeah, that's all for sampling. I will discuss the image and how an image can be considered a signal in the next video, and I would like you to try out the stem function in MATLAB. And I would like you to take a sine wave. Okay, sample it at very different frequency. And observe the results. That's it. This will be the mode. So yeah, that's it for this video. I'll see you in the next one.